Well, let's do another 3 examples that utilize the difference and the sum of 2 cubes formula. Let's look at the first expression. It's definitely a binomial. We have 2 terms and we have a difference. But are they perfect cubes, the terms? No, they are not. So should we stop trying to factor out and put prime here as the answer and identify that we cannot factor this expression? Well, before we give up, we always should look at the expression more carefully and maybe trying to find the greatest common factor. And we do see the greatest common factor here, which is 2. Let's take 2 at the greatest common factor. What is left here is 27, since 2 multiplied by 27 is 54. And what we have here is 8y cubed. Now, inside the parentheses, we have the difference of 2 cubes, because this is a perfect cube and this is a perfect cube. So let's identify our a, which is 3, and our b is 2y, because 2y cubed produces 8y cubed. And then we can use the formula. But what about this common factor 2? Please don't drop it on your way. Carry on until the very end. This is part of your final answer. So we still keep 2. And we need to put, since this is the difference, a minus b, that becomes 3 minus 2a. Now we need to square a, which is 9, 3 squared 9, plus a multiplied by b becomes 6y, 3 multiplied by 2y is 6y, plus 2y squared gives us 4y squared. And this is our answer. And C2 is part of our final answer. This is how we factor this expression. So we used first the greatest common factor, and then the expression that was the difference of 2 cubes emerged after we factor out 2. Let's look at our second example. 2 terms, the sum here, and both terms are perfect cubes. So we can identify our a, which is 4x, since 4x cubed produce 64x cubed, and our b is 3y, because 3y cubed produces 27y, and this is plus the sum. So we have a plus b in the first parenthesis, 4x plus 3y. Now we need to find a squared. 4x squared is 16x squared minus, as the formula dictates. And now we need to multiply a by b. 4x multiplied by 3y becomes 12xy. And finally we need to square b, which is 3y. 3y squared is 9y squared. And this is our factorization for the sum of these 2 cubes. And let's do our last example. Again, let's look 2 terms plus, so we can suspect the sum of 2 cubes. But again, the first term definitely not a perfect cube because of these 2, and 16 definitely not a perfect cube either. But now we know that before we give up, we need to look at the greatest common factor, which is 2 in this case. So 2 comes out and we keep that 2 by the very end. What is left is x cubed plus 8z cubed. So inside the parentheses we have the sum of 2 cubes. We identify our a, which is x, our b, which is 2z, and then we continue using the formula, the sum of 2 cubes, keeping 2 as part of our answer. X plus b becomes a plus b becomes x plus 2z. Then we need to square a, x squared, minus, and multiplying a by b becomes 2xz, And finally, we need to square our b, and 2z squared is 4z squared. And this is our final answer. And 2, again, is part of our final answer.